So I'm Edwin, and okay, I'll describe myself as a full stack developer. I primarily work with like C# on the front end and Python on the back end and DB2 on like database. And I am based in PTA, right? So I'll be presenting to you about IPFS, which is basically a peer-to-peer cloud storage network. So I'm gonna be talking about IPFS in the context of Web3 and its philosophy, right? And basically, these are the main points: that no single entity should dictate access for any user, and the technology itself should be trustless, right? And the user, they should be empowered. And the way the web is set up today, it doesn't really follow any of this. You have to trust that maybe Google or Twitter or Facebook, they are keeping your data safe, and whatever you are accessing from them is what you should be accessing, right? So even if they decided to shut down their service without telling you, well, then there goes your data. So you as the user are not exactly empowered. So what is IPFS, right? IPFS it stands for Interplanetary File System, and it's like I said, it's a peer-to-peer data storage network that uses content-based addressing as opposed to like location-based addressing to find, well, the content that you're looking for. And it aims to be verifiable and have your data immutable. Right? That's where the technology being trustless comes in. Okay, so when I say it identifies content by like, well, a content identifier instead of like a location, this is what basically it means. I'll break it down for you guys. So your content identifier is broken down into certain sections. Right? There's a hash, which is basically a hash of your data, but there's also metadata attached to that, right? Because this was designed with extensibility in mind. So in the binary format, the first part of it represents the CID version, your content identifier version. So like, should they be other versions in future, then yeah, they should be able to give you that particular information. The second part is the coded. How are we encoding whatever data that we store? And then you have your multi-hash, which is, well, the hash of your data, right? In the string format, you can encode that binary format in whatever base you want. So it could be base 58, 34, 16, whatever, but you still have to tell the next person that this particular string is encoded in this way, right? And then what makes up your multi-hash is that it's the information, like it's the algorithm you use to hash your database, the length of the data, and then the actual hash data itself. So this is how we go about identifying our content. So that just represents one file. How do we represent an entire directory, right? So we would essentially we'd just hash the file, and then the parent of that file, that will be like the folder itself. The hash of that is comprised of all the hashes of the child nodes, basically all the files in the directory and the name of the file. And then we hash that, so forth, up until we get to the root node. So this means you can verify that the data you are getting from whoever is the data that you wanted, right? So you can actually recalculate all these hashes given the root node and the data. Okay, so that's how files are represented. That's how we verify files. But how do we find files in a peer-to-peer network? So because we use content-based addressing, we have a CID, and your node would have an ID. And your node ID is actually a hash itself, right? So currently IPFS just uses SHA-256. So the benefit of that is the string is the same length. So we can actually calculate something like distance. How far is this ID from this ID, right? And because we also hash our content, you can actually calculate the distance between your node ID and the content ID, right? So if I'm looking for content and I get a request as a node, I'm gonna ask the node that's closest to that content as to whether they have that content if I don't have it. And if they don't have it, they can ask the node, like in the nodes they have access to, who's closer to that content, if whether they have it, and so forth, up until that is resolved. Right. So later on, I'll explain what I mean exactly by distance. similar, it works the same way when you're uploading content. You tell the nodes that are closest to that content ID that, hey guys, I have this content, you should store this. So in case someone else is looking for it. Okay, so yeah, now explaining the whole distance thing. So IPFS uses a distributed hash table for, well, node IDs, but instead of giving every node information about every other node, a node only holds like a specific kind of data on it. So, and these data is like separated into buckets. Bucket number 0 is all the nodes that are furthest from you, right? And on bucket number 1, it will be like nodes where you say only the first bit with. And then on bucket number 2 is nodes that you said the first 2 bits with. And on bucket number 3 is the nodes that you said 3 bits with, and so forth, right? And each bucket has a maximum of 20 nodes. So how we calculate this distance is we basically take the hash in its binary form, and we perform an XOR operation on it, right? And then that's how we can actually calculate the distance on the node. So if you had to do an XOR operation on your node ID on your node ID, it'll all be 0. So the distance is 0. So that's how you calculate the distance between a node ID or a CID, right? So all information about any content is stored so on the node that is the closest to that content. That's how we find content. So okay, that is what we have for our route table in our distributed hash map. But that is not enough information. As much as it's nice to say, this is content-based addressing, we still need to know the location of the file itself, right? So we also have to have other information on our nodes. First, we'd have a mapping between like the CID and the peer ID. But you also need addresses for those particular peers. So you'd have a mapping for your peer ID to whatever the address is. So you can actually go and retrieve the address from them. And okay, let me just do the number part on this. So yeah, if you look at demo text, it will give you this CID. This is in its string format, right? Let's go back. Let's do this. Yeah, this is like the string format of your CID. And you'll see, first part is what base it was encoded in. It's in base 58. Second part is the version of the CID. This is version 0. This is the encoding and what algorithm was used to hash the content or the contents of this particular file, right? And this is our multi-hash. Okay, let's see a tree structure. So this would be like a directory, and each one of the child nodes have their own hashes, and every file there will have its own hash, and the directory will have its own hash. So that is how you could verify that the content you're asking for from the network is, well, the correct content, right? Nobody changed anything. Okay. Okay, but like it's all well and good. Now we can store data, we can retrieve data, we can verify that the data was never changed. But how do you guarantee persistence? How do you guarantee that that next node is going to keep your data on their machine, right? And like with every Web3 solution, there's a cryptocurrency for it. Right? We just like, yeah, that's what we're going to do. So Filecoin was invented to be the incentive layer for all of this, right? So they pay data providers to store the information, and they pay verifiers to actually verify that that information still exists on that particular machine for the time frame. And yeah, that concludes my talk.